So now in today's class, these are the things which we are going to cover. Some of the things I'll cover today, and the next things I'll cover in the next slide. So where MapReduce is used, we'll also look at the traditional ways of solving the same problems which we used to do when I was young. Okay, and we will also look at MapReduce way of solving a problem. We'll also look at how does a MapReduce program look like. Okay, we will show you in Java. We'll show you in Unix also how did we used to do the same thing earlier. Then we'll also cover Hadoop streaming. Okay. So Hadoop streaming is the way in which you can actually write MapReduce program if you do not know Java. Okay, so all the people who are from Ruby, C++, Python, Perl background can be a little happy because I'll teach you how to write MapReduce without knowing Java. Okay, we'll use a couple of languages and then I'll leave it to you. So you'll have a lot of assignments there. Okay, great. Then we'll also look at what is a combiner and a partitioner. Don't need to worry too much about it right now. These are terms which you just need to remember. Okay, that there is something called a combiner, there's something called a partitioner. I will go into details why it is used, where it is used. We'll also show you the classes in Java which have where this is implemented. We'll look at the MapReduce data flow. Okay, we'll also talk about input splits, how they're done, and then we'll look at the input-output formats. Okay, so this is important. There now we know we have unstructured data that can be in many formats, right? So it can be in. So these are the defined formats. For example, there is a text format. There's a key value text format. Okay, we will be also looking at n-line. Okay, we will be doing MapReduce too. Okay, and sequence files will be for images and audio files there. Okay, so we will be looking at each of these things, and don't have to worry too much about anything right now. It will be very simple. It's actually very simple. Okay, it's not difficult at all. Okay, so where is MapReduce used? Okay, so we have a lot of data from the weather forecasting. Okay, where we have a lot of climate data, which is say from since the beginning of the century. We need to analyze what will the maximum temperatures. We'll do a lot of predictions based on that. So that's one place where we'll be using MapReduce. Can you tell me where in healthcare will we be using? Okay, patient reports, auditing, product distribution, right? Claim processing, right? ECG monitoring, machine data flowing in the tools, says Vamsi, right? Identifying fraudulent claims, okay? DNA research, Sachi, right? That's true. Scanning data. So yeah, so there are a lot of applications. We have a lot of unstructured data from all these industries, and these are not the only industries. There will be a lot of other industries where, say, utilities side, oil and gas industries, right? We'll have a lot of data which we need to analyze, and we'll see how we used to do that earlier. Okay, now okay, so we'll just see how we used to do earlier, and then we'll see what are the challenges there in the earlier methods, and then we'll see how Hadoop and MapReduce solve that problem. Okay, so let's look at one of these examples. Now what I've done is I've picked some data from this site, NCDC. This is climate data, okay, and so this has for each of the years, right? It has the data here. Okay, let me show you some of this data, how this data looks like. Okay, so that was on the PPT. Now let's see this data. Let's see where I got this data, and we'll see what do we do with this data. Okay. So let's look at year 2013. Okay, Rahul, are you able to hear me now? I mean, I think there may be something wrong at your end as well, because everyone else says that I'm audible. Okay. So this is one data set, huge data set. So there'll be such data sets, and I've just picked up one from that file. There'll be terabytes of such data. Now look at this data. It's like a log data. Lot of columns are there, and it is delimited by space and tab. Okay, so you don't have to worry too much about what are all the fields here. The whole idea is to present it to you. Yeah. So if you want to see what all is there, let's see what is there in this data. Okay. Yes, it is. That's right, Ashish. Okay. So now it says that WBAN number is something which we do not care too much about. Then there is this local standard time, which is from column 7 to 14. We have columns longitude, latitude, daily max temperature, daily min temperature, daily mean temperature. So lot of such data is there here. Okay. Now what we want to do probably with this is that in this, if I have to say find what in every year, right, what is the maximum temperature which occurred, or how many days can be classified as hot days, how many days can be classified as cold days, right? So can anyone tell me how will you find it if this I mean, forget about Hadoop, right? How will you actually find it out? So if I have to tell you that for each year, give me tell me which is what will be your traditional way of finding it out? How will you do that? Yeah, the columns are fixed, Vamsi, right? That's true. Okay, so Sachi is telling you we'll load data in Oracle and SQL it. Okay, go through and row and column value, max function, right, right Vinay. Okay, and evaluate for a range. Okay, okay. Is anyone from the Unix background here? Yeah. Things with awk. Now the challenges are that, and I'm sure you will yourself figure it out. So what I'll probably ask you to do is write the awk program to run it on a small data set, which is one of these. These are few KB files. Now when it becomes terabytes, right, then the problem is that as we saw right from the first class when I was telling you what is the challenge in the world, not storing data. It is reading it and analyzing it, right? You remember that thing which we showed you in the first class itself, where we showed you the time to read from a single machine versus time to read from a distributed fashion. Everyone remembers that figure? Right, seek time is the problem, right? So that's why awk also or any such program will have a problem. So what could be the probable solution for that? Even if we have, so we can split that data, right? So if I had so many files, I could split this data, do a grep, or I mean, I've made it very simple. We did not need to do any awk. We just need, you can do grep also. For the people who do not know grep, please look in. Grep is the command to take out a few regular pattern from in Unix. Okay. So whoever does not know grep, go do a googling on grep as well, right? So if we had, as we saw, right, if we had huge amount of data, what would we do? This is your very big data. Now, one of the files which we saw was this data only. So what I'll probably do is split this data into multiple files, okay, and then do grep on each of these. Whatever matches, do a cat and create a final output, right? All matches can come here, right? So is it making sense? That will be that obviously the next thing which you would think of doing. Is that correct, guys? Anyone who is not with me till now? Just say no. Everyone is with me? Great. Now you have to tell me, the next question I'll ask is, if everyone agrees with this, then what are the challenges in this approach? Can someone throw some light on that? What are the challenges in this approach? The approach is very simple. You have very big data, split it into multiple data sets, run it on different machines. Okay. Splitting the data. Okay. Time consuming. It was time consuming. That's why you split it, right? So don't worry, Orca, what pattern? Let's just, yes. So one very good thing which Dipankar has told me is, yeah, reliability is one answer which I've got. Guys, yes, very important thing, reliability. Failover mechanism is what Dipankar is telling me. What else? Is there anything else? Computation is not done, Avinash, at one place. We can compute it at multiple places also. So the solution is simple, right? What I've done is, what I'm saying is, all this, you split this data, put it in different machines and do that thing. Do it parallelly only. Now I'm not saying that do it in sequence or in single machine. I have agreed that we can do it in parallel. So you have said 1 terabyte of data, okay, split it into say 100 parts, and then do grep on different machines, and then do a cat. So this is feasible, right? That's what this is feasible. If I had to do these two operations, this is feasible, right? Great. So now I want to know what are the challenges in this approach. Why do we need something else? Something which has taken the market by storm. So Vamsi, see, Hadoop is also working on Unix only, right? This can be done in other things also, other languages also. Unix is one way of doing it. I mean, similar things will exist in other languages as well, right? Other platforms as well. So that's not really the thing. So why did we, if we could do this here, okay? Okay, so now Rajat has given me one answer. Okay, Tush, okay, great. So Rajat is saying failure on one machine can corrupt the entire matches. Right, so that's one good answer. Okay, it is not robust as Tushar is saying. Tushar is saying the job to split and integrate after CAT is still a manual process. Well, my friends Dilip and Ravi will quickly create a script for that as well. That should not be a big problem. They can do that. But then yeah, I've got very good answers now. I think most of the answers I've already got. Right. Orca is saying instead of reading record by record, it will be read block by block. Okay, fine. But finally you will be doing a record. It will be read completely block by block. But when we do a analysis over it, it will still be a record by record analysis, right? And we'll show you that. So that's not really the reason. See, have you ever heard about critical path? Everyone knows what is the critical path in a. Okay. Okay, some people have, some people have not, right? I'm sure whoever has done a PMP exam, they would have, that is the first thing everyone will know. But you don't need to do PMP for knowing critical path. See, critical path means that, okay, Ravi, yeah, great. Okay, okay. Yeah, yes, Ravi, right. Sachai ko certificate ki zarurat nahi hoti, that's true. So don't need a PMP to know critical path. You can know critical path and still not be a PMP. Okay. But anyways, you don't need any, see the reason I'm putting this thing here is that one very important thing is that now it will also depend upon the machines which you are using, okay, and their processing capacity of each machine, okay, will be important here when we are splitting this data, right? And if a machine is, one of the machines actually is a smaller processing capacity machine, then that will become the critical path and it will delay the process for everything. Is this making sense to everyone? Say for example, this grep is done very slowly. All these were ready. This took 2 hours more. So everything took 2 hours more, right? Is that, yes. So, right, is that making sense? So that's what critical path is. So anything, now I want Ravi, who is a PMP, to define critical path for me, and I'll read out that definition so that yeah, Ravi, I want you to actually speak if you can, if you have a microphone. Okay. So Ravi is saying I'll not tell. Who's going to define critical path for me? I mean, you have Google as well. Everyone can go to Facebook and look at that. But you have to define. Samrish has gone there. Rahul has gone there. Ramesh, Ranjit, Vamsi, Vinod, all of them have gone there. Other people, Shriram, you already know what a critical path is? You might as well appear for the PMP exam after this class, man. Because you're going to know what a critical. See, how many of you are actually managers? Very good. Rajat has given me the right answer and he's a, okay. Okay, Ramsi, don't worry, you can check on your mobile. Okay. So Rajat says I'm PMP certified. Congratulations, Rajat, for that. And it's a good thing to, no, I can't trace mobile phone usage. No, I can't do that. I can't do that. So yeah, so Rajat has given me the definition. Thank you, Rajat. I'll just read it out for everyone. And it's actually a very good definition, a very accurate one. Rajat says it's the amount of time to finish the job without delaying the next milestone or actual completion date. Right? I'll repeat it once. Please pay attention, everyone. And I want everyone to say thank you to Rajat for that. Rajat is saying it is the amount of time to time taken to finish the job without delaying the next milestone or actual completion date. Right? So does everyone know what is critical path now? Everyone is saying thanks to you, Rajat. Okay, great. So now, see, this is the beauty of having so many people in the class, because everyone can give us something. So Rajat has yeah, great. So now, as I told you, right, if one of these greps end up becoming a critical path, See, first thing is, can you really split the data into equal parts? That's one challenge, right? Because you may not be able to split that. Now, if this is yearly information also, it is possible that in some years there were more records, in some years there were lesser records, right? And it is very difficult to actually split that. Does everyone understand that? Does everyone agree with that fact? So, and even if we split them equally, then the next challenge is the critical path problem, right? So two problems we understood. First is splitting in equal proportions may not be the best way to handle this, because sometimes same data which we would have actually easily managed, it was in the same split, would have gone into the next split and it would have led to a problem. I'll show you this example of this later on, okay, where this could be a problem, okay. But on a higher level, you've understood what I'm trying to say, everyone? What I'm trying to say is, it may not, sometimes it may be best to keep related data in the same split, right? So if I'm actually looking at a yearly distribution of something, and in 1 year the number of values are more, and I want to just figure out what is the maximum in that year, it may be a good idea to actually put it in the same split. Instead of splitting 1 year's value here and putting it across in this, if you have 2 year values, right? Then what I get is not the yearly max, but the max of the split, right? Is that clear to everyone? If whatever monologue I just gave on the equal split thing? Anyone who is not clear, I'll explain it again. Great. So I'm getting a lot of smileys today. Thank you very much, guys. Clear, the bunkers is clear. Great. So yeah, keep on sending smileys if you're able to understand this. If there is anything which you're not able to understand, feel free to stop me. Okay. Great. Thanks, Parthivan. Thank you very much. Okay. So now, one challenge which we've understood is that dividing them into equal splits may not be the best idea. And if we do not divide them into equal splits, then we will surely get into this critical path problem. That's also clear to everyone. But even if we divide them into equal parts, then also we might get into, look at the usage of the thing, we will surely get into a critical path problem when we do non-equal splits. Is that correct, everyone? And if we do equal splits, we might get into a critical path problem here. Is this sentence clear to everyone? Or has it gone over your head? Okay, got a lot of smileys, so I agree, I understand it is clear. Okay. Now, anyone in the class, Tushar, Shriram, who are not in the last class, if for some reason you're not able to follow, right, please do not hesitate in asking. All of our batchmates have agreed that I take a little longer to teach something, so they have agreed, and they have said that it is fine. They are okay to wait a little long. So please make sure that don't hesitate to ask. Okay, thank you, Shriram. Okay, and thank you everyone else. Vinod, you are still with us. It's not too late for you, not sleeping anymore till now. Okay, so now these two things. Okay, great. So two things which we understood. One was that splitting is the natural way of doing things, but the challenges with splitting could be that splitting equally has its own challenge, non-splitting equally has its own challenges, right? And then you do a CAT. Okay. Now these are the two very important things. The more important thing, then another important thing comes in the reliability. One of the machine may fail, right? How will you make sure that the reliability thing is taken care of, right? That's another challenge, right? Isn't it, guys? Smiley quickly if you agree to that. If one of the job fails, then probably, thanks Sachi, thank you very much. So if one of the job fails, then you have a lot of trouble, right? You don't know whether you got the right answer or not, right? Because if you are looking at the maximum temperature in a century and the machine on which the hottest year was there failed, then you get inaccurate results, right? True or not? So reliability plays a very, very important role here, right? So that's very important. Thank you very much for be interactive in the class. I'm sure everyone will understand at the end of it. Okay. Now, so that's very important thing. Now, failed jobs, who's going to handle, right? Now, tell me, these are all running in a different machine. Who is going to run the overall job? Someone has to run this overall job also, right? Which Dilip would have written in his script that split this, do grabs are done here, then do this CAT and then final result, right? So no, Rajat, let's not get to job tracker. Okay, let's not. We are not talking about Hadoop. We have not reached Hadoop till now. Okay, let's try to understand who is going to do that overall job here, right? So that's one challenge, isn't it, guys? So the challenges which we have are quickly. Can you quickly write it down on the chat window? What all challenges I talked about till now? I'll also repeat it once again because that's all, those are the things which are important to understand. Reliability 1, splitting the file, very nice. Unequal split has its own challenge, right? Master job, very nice. Reliability if one machine is down, very nice. Okay, one more thing, critical path. Incorrect results due to failure, right? Very nice. So these are the challenges, right? Now theoretically and practically also this is all possible, right? You can write a very good framework, which I'm sure a lot of you who are hardcore programmers and I'll probably say Avinash and Ravi, I'll just pick these names, or Dilip, because they've told me that they are hardcore programmers. Scalability also is a challenge, right? Dilip tells me, right? Who have done a lot of programming in Unix. They will claim that if a company gives them this job, they will be able to do it. Okay. So yeah. So Ravi, I will agree when you send me this awk program by the end of this class. Okay. Okay. I'm just being a little early in the press, but I want you to send the awk program. Okay. Yeah. Okay. Thank you. No, not at all, Ravi. Not at all, man. Not at all sarcastic. I'm just, I know you guys last time also I had a class with you. I learned from you guys as well. So definitely you've shown me that promise. So please, so yeah. So coming back to the fact that these are the challenges which we have. Now, any great programmer or any great guy who claims that, I mean, not even claims, I mean, a lot of you people have been from the software background. I'm sure a lot of you will be able to create such a program, right? How many people think they'll be able to create such a program which can take care of this? Avinash says yes. Rajat also says yes. Rajat, I will come to that. Okay, Rajat Behra. There are two Rajats in the class, so please don't get confused. I will call Rajat Rastogi as Rastogi and Rajat Behra as Behra. Is that fine with both of you? Yeah. Okay. So Behra is asking me a question. Just confirm my understanding on responsibility challenge. Who will be doing what and when? Okay, Rajat, I will. That is not a very good question to ask at this point of time. Very soon we'll come to know that. Okay, but I'll quickly answer that. So there will be one overall job which will be managing all these things, splitting and then pushing these jobs on different machines and then doing a final cat and showing it. That's the overall responsibility of someone who has to do it. Then these machines have to do this grep. Someone has to do this cat, right? So we have, these are the kind of problems which we'll have. These are the things sure. So Ravi says difficult, not sure. Okay. Sync sort is what, okay, sync and sort, right. Okay. So with JCL and COBOL, Dipankar will be able to do that. Okay. Now, how many people think they'll not be able to do that? Time taking is what Ashish says. Great. So there will be a sorting also involved, right? Very nice. So I think by the time I reach MapReduce, right, you would have actually told me that. No, I'm not saying at this point of time. If I give you 2 days time to write something like this, so through ab initio I can do that, says Orca. Okay. So if I give you 7 days time, can you write this program and give it back to me, which can take care of all the reliability issues as well? Sriram says I can create a OLAP cube and get it done. Okay. Okay. So I'm sure some of the people can do it, some people cannot do it. They want to use different technologies for doing it. It is impossible to determine the failures not speaking to each other, right? So it's, yes, it is very difficult, right, Ravi? That's true. So now who does, so you know why do we need something else? Now everyone understands. God gave Hadoop, why use stairs when you have a lift? Wow. Yeah, so Ravi says God gave Hadoop, why use stairs when you have a lift? Right. So very nice. Thank you very much. Thank you very much, Ravi, for that great piece of poetry is what I'll call it. I'm not very good at English, so please, wisdom is what Dipankar says, right? So that is a wisdom nugget from Ravi. Okay, my friend who is lift. Okay, so Vamsi is saying lift can stop in case of power failure. When we are over, what do we need to? Okay, so Ramesh is telling when we are over with, then we need to use stairs sometime. Okay, use stairs in case of emergency. That's why I'm telling you guys, learn awk. Okay, so not Hadoop is going to come to your rescue every time. Not every time when you are given a job, the data set will so use that you will tell your management that I'll use Hadoop to do it. Okay, they'll throw you out. What you will get in response is a pink slip. if you tell them that I want to look at these logs and use Hadoop to do this. Okay, so all of you should actually learn awk then. Awk comes very handy. Very few people know them. You can also boast that you know awk in your office. Okay, so definitely learn awk. Okay. Now that we've established the fact that there are some challenges with the traditional way, and we've also looked at them, that processing capacity of each machine, splitting the jobs, the critical path problem, reliability, failed jobs, who runs the overall job. These are the challenges, and so we got a lift then, right? And the stairs could be awk, but we got a lift, as Ravi says. That's where our way of doing things, the MapReduce way of doing things, helps, right? So Dipankar, are you clear? Why do we need MapReduce now? Let's not go to MapReduce is a key value pair of programming, which will be used to do this some definition, and then you become some XYZ certified Hadoop developer. Don't just rely on that. Okay, so it's very important to know where to use it and where not to use it. Okay, so now can you tell me, if the data set is small and if the files are small, okay, let me ask that question later. Okay, not the right time to ask that question as well. I'll ask you that question by the end of this class. Okay, if I don't ask you this question, please remind me that you had to ask some question on file sizes. I'll ask you that and make that clear then. Okay, so let's move ahead and let's see. Now I have introduced the term MapReduce on this file, but I'll not talk about MapReduce still. Okay, I want to actually understand from all of you